So in class today we learned how to do quadratic functional form. We regressed salary on education and education squared, and we learned that the effect of the independent variable depends on where the independent variable starts. For example, if we go from 12 years of education to 13 years of education, it boosts our salary by about $5,000 per year. If we go from 9 years of education to 10 years of education, it boosts our salary by about $2,500. So the effect of the independent variable depends on where we start. In this podcast, I want to show you how we do this in R. So I loaded my CPS data. That's data 63,000 observations, 10 variables. And I want to create a new variable that's education squared. I can do this with one line of code. I want to create a new variable in the data frame called data. So I'm going to type in data and then the $sign and a name of the new variable that I want to create. I'm going to call it edu squared. And to it I'm going to assign the square of the edu variable from data frame data. So let's see what happens if I execute this line of code. I'm going to do Control Enter. And no error. And look, now I have 11 variables. So let's see, here's the new variable edu squared. For this first person, it's 144, which is square of 12. So that's terrific. I'm really happy about that. Let's now estimate our regression. It's the same way we estimated it before. Salary is the dependent variable. Education, edu, is the first independent, and then we have a second independent variable that's education squared. So I'm going to hit Control Enter. I'm going to summarize that model, and here are the regression coefficients that we saw in class. So in the quiz, I want you to do the same thing using age instead of education. If you feel like it, you want to play with, and you want to play a little bit with ggplot, my favorite plotting function. You would need to install a ggplot package, and then you could plot the data that we have. You could plot salary on the y-axis, education on the vertical axis, and plot all the data points. And here I'm actually also going to add a smoothing function, essentially our fitted values using a linear method, but using a formula that's a second-degree polynomial. Now, second-degree polynomial is, of course, a quadratic function. So if I say, well, let's run this, a picture should appear, and there it is. So there's our education and salary data, and we see that we could fit that with a quadratic model. That's a parabola that's facing up, which we actually knew that it was going to be facing up because we saw that the coefficient on the quadratic term was positive. And the bottom of the parabola should be around 5.9. And we calculated this in class as well using this formula, which is just using calculus. And so the minimum salary happens when your education is 5.9 years. And let's see if that corresponds to the graph. Yes, indeed, the parabola seems to be at the bottom right about 5.9. So go ahead, try this with age. If you have any questions, let me know.